Hi, in this video we're going to be having a look at the acidic environment, and I'll be talking about some of the basic concepts that you need to understand in the acidic environment. I will start off with the definition of acids and how acids undergo ionization in water to give you the different types of acids like monoprotic, diprotic and triprotic acids. I will then move on to acid conjugate base pairs. We'll have a look at pH and what pH means. I'll then talk about amphiprotic substances, and finally we'll have a brief look at buffer solutions. So just to start off, definition. The definition of an acid has actually evolved over time. Lavoisier was one of the first people to try to explain acids in terms of chemistry. Before that, people would just say, acids have a sour taste or something else. So it's based in terms of its properties rather than its actual chemical composition. So Lavoisier actually said that acids contain oxygen, but we know that bases contain oxygen as well, like sodium hydroxide, that contains oxygen. Humphrey Davy then came up and he said acids contain hydrogen that can be replaced by a metal. This definition was then improved on by Arrhenius, and Arrhenius said that acids produced hydrogen positive ions in solution. The definition that we'll be using in the rest of the video, and the one that we use commonly, even though it's not the most recent one, is Bronsted-Lawrence definition, and it says acids are basically proton donors. So an acid is a substance that donates a proton. And what happens is an acid will dissolve in water to produce H positive ions. So let's have a look at an acid. Once we know hydrochloric acid, HCl. I take HCl and I put it into water, right? What will I get? I will get H positive plus Cl negative plus H3. Sorry, the H positive is going to go with the water, so that will just give me H3O positive and Cl negative. Alright, so this is actually called the ionization of an acid. What has happened is, this is the acid, it's given away its hydrogen to water. And as it's given away its hydrogen to water, it's made H3O positive and Cl negative. Another type of acid is sulfuric acid, H2SO4. Right? And I add it in water and I'll get H3O positive, I'll actually get 2, and I'll get SO4 negative 2. We can actually see that H2SO4 has actually got how many hydrogens? 2 hydrogens, right? So when it gives away, it can actually make 2 H3O positives. So really, H2SO4, this is called a monoprotic acid. This is called a diprotic acid. And an example is H3PO4. Phosphoric acid is a triprotic acid. Alright? Monoprotic gives away 1 hydrogen, diprotic gives away 2 hydrogens, triprotic actually gives away 3 hydrogens. All acids in water will ionize in water and make H positive ions. Now we're going to have a look at weak. So that's the definition and ionization of acids. Then we move on to a weak acid, a strong acid, a concentrated and a dilute. So we're going to have a look at the difference between weak, strong, concentrated and dilute. A weak acid is something that partially breaks down. So this will partially ionize. This will completely ionize. An example of strong acid is HCl, H2SO4. We saw they actually broke down in water and made H positive ions. An example of a weak acid is something like ethanoic acid, which is CH3COOH. When I put this in water, alright, this will actually be an equilibrium reaction because not all of this guy will break down. So I'll get this. Remember, it's got to give away the hydrogen, so it's left with CH3COO negative and H3O positive. But this is actually an equilibrium reaction. Because this does not completely break down, it's an equilibrium reaction. In the case of a strong acid, this would not be an equilibrium reaction, this would just go all the way forward. But this is a weak acid, So this will be an equilibrium reaction. Not all of CH3COOH will break down. So we can understand the difference between a strong and a weak acid. Now, the definition of something that is concentrated is basically it contains a large amount of high solute